Hello folks and welcome back. Today we're going to be continuing our discussion about factoring equations, factoring specifically quadratic equations. And today we're actually going to talk about how we solve quadratic equations. We're going to solve a quadratic equation using a factoring method. Before we get started, I just want to talk about a little bit of terminology, some things that I want to make sure that in case I say these words that you understand what they mean. If I say solve the quadratic equation, or if we're looking to find the solutions, or if we're looking to find the zeros, or solve for x, all of those mean the same thing. All of those are just a slightly different way of expressing things that just what we're going to be doing for this whole process. So in case in this class or somewhere else you see it phrased something different way than you're used to, don't worry about it. All these things mean the same thing. They're just different ways to ask for the same result. Okay. When we're solving quadratic equations, what we're looking for x values that ultimately make it true. In this particular case, we are looking for x values that make our function equal 0. We're going to try and get everything set equal to 0. And one way we do this is by factoring. Once we've factored an expression, we use what's called the zero product property to help solve the equation. And I will describe this better in just a moment here, but what the zero product property tells us is if we have two things that are multiplied together, to equal 0, well, either those things have to, one of them has to be 0. Either A equals 0, B equals 0, or both A and B equal 0. We're going to kind of focus on this here. This idea of both A and B equaling 0 is what we're going to use to solve for x. So let's go ahead and take a look at some examples. This is the example I want to see here. So as we look here, we have x squared plus 3x minus 18 equals 0. Now we're going to factor this. We're going to use what I like to call the basic factoring method, and I'll explain that in just a moment here. I got to get my writing tool set up and ready to go. So with this, I have x squared plus 3x minus 18 equals 0. I'm going to factor this part, and it's being set equal to 0. So with this, I'm going to set up a couple of sets of parentheses here, equals 0. Alright, so how do we get x squared? Well, that has to be x times x. If you recall, the next thing we look at is this symbol here, this minus sign. We multiply two things together to get a negative 18. Well, you get a negative 18 by multiplying a positive number and a negative number together. Positive and a negative number. In this particular case, we're looking for factors of 18 that combine to give us this plus 3x. Well, those factors are going to be a plus 6 and a minus 3. I'm not going to go into the details on that right now, but this is indeed factored appropriately. Now, what we're looking for with this, though, is what x values make this true. What x values can I plug in and make this equal 0? Well, we're going to use that zero product property. Before I go on to this, let me just give a brief description of what that zero product property looks like. What that means is if I have two things multiplied together, A times B equals 0. I'm going to look at what happens when A equals 0, and I'm going to look at what happens when B equals 0. This is how I'm going to split this up. So in this case, our A is being done by x plus 6. X plus 6 is our first term. We're going to set that equal to 0. We're also going to set x minus 3 equal to 0. We're going to see what values make each of these equal 0. Well, these are both pretty straightforward. I'm going to subtract 6 on both sides. Being in Algebra 2, this is something that shouldn't give us too much trouble. And here I'm going to add 3 to both sides. X equals 0. Oops, sorry, I got that last part wrong. X equals 3. There we go. So setting each factor equal to 0, I get my two solutions. X equals 3 and x equals negative 6. Now we should go back and check and make sure we did the work right on that, but these are definitely correct. If you take negative 6, plug it in for x, we do get this equals 0, as well as x equals 3. Let's do another example. Let's take a look at this next one. In this one, we have negative x squared plus 16x minus 64 equals 0. The thing that makes this a little bit troublesome is we have this negative x squared out in front. Negative x. Man, I don't like working with negatives. So what we have here is a really cool algebra trick that helps us get rid of that negative, but still work with and make it ultimately easier to work with. Negative x squared plus 16x minus 64. I'm going to divide both sides by negative 1. As long as I do it on both sides, it is a valid algebraic move. Now the cool thing about this, what is 0 divided by -1? That's 0. That doesn't change one bit. But on this other side, I get something that's much more manageable. I get x squared minus 16x plus 64. I'm running a little bit out of space here. X squared minus 16x plus 64 equals 0. From here, we have two ways to factor this. We could use our basic method, or I'll just mention this briefly. This actually falls into the special factoring pattern. This is actually a perfect square trinomial, because this is a perfect square, x squared, 64 is a perfect square. I'm not going to go into that right now, unfortunately. I'm just going to use the basic method for this. We have x and x. The plus sign, we get a positive 64 by multiplying two things that are either both positive or both negative. Specifically, in this case, they are negative. And we're looking for factors of 64 that combine to give us 16. Well, those factors are 8 and 8. Now we can set each of these factors equal to 0 using the zero product property. Oops. We can x minus 8 equals 0 and x minus 8 equals 0. But that's a little bit silly because they're the same factor in this case. We really just have to do one of them. I'm going to add 8 to both sides. We get that x is equal to 8. That is our one solution. There's one solution to this one. It's a very special case, but we have one solution. All right. So those first two both use kind of that basic factoring method. This next one we're going to look at, though, is a special pattern. What we should recognize about this one is 4x squared. Ooh, that's we have 4x squared minus 25 equals 0. Whenever you have two terms, you know something a little bit fishy is showing up here. And because these other ones had 3 terms. These had 3 terms, and we're doing one that has 2. So what we need to recognize here is that, okay, 4x squared minus 25, this is the difference of two squares. What did I square to get 4x squared? I squared 2x to get that. What did I square to get 25? We squared 5 to get that. So if you look at one of my previous videos that's dealt specifically with special factoring patterns, we see that this turns into 2x plus 5 times 2x minus 5 equals 0. Now we're not done though, so we factor it, but we're still looking for what are the solutions. So we're going to take each of these factors and set them equal to 0. 2x plus 5 equals 0, and 2x minus 5 equals 0. And I'm running a little bit out of space here. Let's grab this. I'm going to have to reset my pen, but that's okay. All right, I'm going to take each of these and I'm going to set them equal to 0. Subtract 5 on both sides. So I have 2x equals negative 5. Divide both sides by 2. And x equals negative 5 over 2. That's one answer. Our other answer, add 5 to both sides. And we get 2x equals 5. Divide both sides by 2. And x is equal to 5 over 2. There are our two solutions for that equation. And again, if we go back and check, plug those in to the original, we'll end up getting the same. We'll end up getting the that it is equal to 0. That it does work. Okay. All right. So if you need to see any of these, rewind the video, check them out. I'm going to clear this now, and we're actually going to take a look at the last two examples that we have. So bear with me as I take a moment to clear these out. Don't need any of that for this next example, and we don't need any of this. Oh, we need some of that stuff. And last things. Okay. So what we have now, we have our last two examples here, and both have something special that we haven't really talked about yet. I didn't want that. I guess that works, whatever. Okay. Okay. So we have x squared minus 3x equals 0. This one, it only has two terms, so again, something fishy might be happening, but this is not the difference of two squares. We don't have two perfect squares that we're dealing with in this situation. So now we need to think, well, what else can we do? How else can we try and factor this? Is it not factorable? Possibly. But in the last video that I did regarding factoring, the last thing we talked about was how do we handle things that have the same terms. This is an x squared minus 3x. These have a common monomial between them. So I'm going to factor out that common monomial of x out of these. So x factors out of both. I'm going to factor x out, and I'm left with x minus 3 equals 0. Now with my two terms, I'm going to now take each term and set it equal to 0 using the zero product property. Take x equals 0 and x minus 3 equals 0. Hey, look, there's one solution. Add 3 to both sides. We get x equals 3. There's our other solution. There are two solutions for that one. Now, in every example that we've looked at so far, we've had everything set equal to 0. This equals 0, this equals 0, all the other ones are equal to 0. Well, this one we have 2x squared minus 17x plus 45 equals 3x minus 5, not 0. So what we're going to do is we're going to get everything onto one side of the equation. And that is actually a particular skill that is very, very useful in Algebra 2 in general. So this is something you should be able to do. I'm going to subtract 3x on both sides to get rid of this 3x, and I'm also going to add 5 on both sides. So with this, I now have 2x squared minus 20x plus 50 equals 0. From here, there are a couple things that we could do. We could just try and factor using the traditional method. Earlier today, I tried to factor using the Xbox method, and that actually didn't work out. I'm not quite sure why that didn't end up working out, but so that kind of leads us to the next step. Notice how we have 2x squared minus 20 plus 50. These all have a common factor of 2. I'm just going to divide that 2 out. Again, as long as I do a valid step on both sides, it works out. So I have x squared minus 10x plus 25 equals 0. I'm going to set up my factors. Again, x and x. Factors of 25 that combine to give us 10. Well, those are going to be 5 and 5. Okay. I'm going to stop the video here, and I'm going to do the one more problem in a separate video. So I'm going to stop this here, and then I'll get that uploaded. So see you in the next video.